So how many people here already know what etcd is? Okay. How many people here have deployed etcd for something other than Kubernetes? We got a couple, okay. Yeah, a few. Has anybody here had to troubleshoot etcd as part of Kubernetes or otherwise? Yeah? Yeah, okay. Yep, it is time. Yep, so welcome everybody to the etcd project update. Etcd and etcd operator. I am Josh Berkus, and I'm a documentation approver for etcd.
I'm Arka Saha, an etcd contributor, and currently contributing to etcd operator.
Yep. And there's a lot of people who aren't here in India with us, who work hard on etcd. These are just actually the current maintainers, but there's a lot of other people who contribute to etcd. And in the future, that could include you. Unless, hey, is anybody here actually a contributor for etcd? Let's change that. But let's learn a little bit. So we're going to talk about a few things here. We're going to talk about etcd 3.6, the latest version. We're going to talk about etcd operator. And we're going to go over features and upgrading and the roadmap for the operator, and the API and some future work. So just for the people who didn't raise their hands earlier, if you weren't aware, etcd is a distributed, consistent document database, sorry. And it importantly is the core of the Kubernetes control plane. It's how we make sure that all the control plane components have a consistent view of what's supposed to be on your cluster. So, with that, let's talk about the latest version, version 3.6. We are very excited about version 3.6 because it has been 4 years since we had a new feature version. One of the reasons it has is we have an all-new, back up a little bit, we have an all-new maintainer team. So this is actually the first feature release under that new maintainer team because the founders of etcd have left the project and it is now a new generation. etcd is actually in 3.6.4 now, so please do install the latest patch release. And wait, hold on. And version 3.6.4 will be the version that ships with Kubernetes 1.3.4 when that comes out in a few weeks. A couple weeks, yeah. When that comes out in a couple weeks, it'll be 3.6. So, first major feature, downgrade. This is something people have been asking for a really long time. 3.6 will be the first version to support downgrade, which means you can downgrade to 3.5, and that's it. And to understand what is important is, how many people here have started upgrading Kubernetes and then run into trouble and had to stop? Anybody? Yeah, I've got a couple of people, right? Yeah, and the problem is we haven't had full rollback of a Kubernetes upgrade because of not being able to downgrade etcd. So now we can, right? So if you were running, say you're running 1.32 right now, you're going to upgrade to 1.3.4, an etcd upgrade is going to be part of that. If you run into trouble in the middle, you can stop, roll back the Kubernetes update, and downgrade etcd and be back on a healthy 1.3.2 cluster. And that's something we've wanted for a long time, which is why we're very excited to be able to do that now. The way that it works is it's just a mirror image of a rolling upgrade, right? So you first tell it to downgrade its communication protocols and how the nodes sync to the previous version, and then you're telling it to actually update the storage and the metadata to the previous version, and then at that point you can restart the etcd members one at a time on the old version. We've also added some some stuff to the health information, which tells you what version of the protocol it's using and what version of storage your etcd members have, so that you can see the process of a rolling upgrade or a rolling downgrade. Another thing that we're doing is both a feature and a deprecation, which will then lead to some backwards incompatibility for anybody who's been using etcd for a long time and has a lot of really old API calls. And that is completely replacing V2 Store with V3 Store. So, hold on, you're getting ahead of me here. So, what's V2 Store? So, V2 Store is the original storage format from etcd 2.0. It is the source of truth for membership data among the nodes. Who is a member of the cluster? You know you're on V2 Store because you see a bunch of files in the old hex format name. Technically, V2 Store has been deprecated since etcd 3.4, but we allow people to continue using it through etcd 3.5, right, with a switch. So next up, V3 Store is the storage format that we got introduced, right, with etcd 3.0. It's been the default since we introduced 3. If you are completely on V3 Store, it's the source of truth for membership data, and it uses an actual directory structure, which is definitely better. More importantly, it uses the bbolt engine, which is a semi-detached project of etcd at this point. Started out as an independent database project. We pulled it into etcd, and it is an efficient key value storage that we use for etcd's data. So what's changing is, in 3.6, that enable V2 switch, it will not be available anymore. So if you actually have old V2 data because you've been running your etcd cluster for 10 years, then this upgrade is going to take a lot of planning for you. We've also added some migration code to make it easier to do that, getting rid of all of the old extra V2 stuff. The final thing is, right now in 3.6, we are still using a little bit of V2 storage during the bootstrap process for a brand new cluster. And we want to get rid of that. And then all of V2 will be gone once we get rid of that. So, feature gates, major development thing. So if you've started etcd with a bunch of optional stuff, we use all these flags that are like experimental something, right? Experimental integrity check, etc., for alpha features, right? We're replacing that with Kubernetes style feature gates. So you'll see if you actually compare the config document for 3.5 versus 3.6, a lot of -- experimental has been replaced with -- feature gate equals whatever. The feature gate format's more better for config files. And importantly, it allows us to adopt a Kubernetes style alpha, beta, and general availability stages for new features that we introduce. And importantly, right now, right, if you're upgrading from 3.5.3.6, this is a big breaking change. And it is going to be annoying if you are using a lot of special etcd flags. But then once we're done with it, we're done with breaking the flags, if you follow me, because the feature gate names will be consistent across versions as opposed to the experimental flags. No, not yet. And it'll make it easier to track which things are no longer experimental, which things are no longer alpha, and which things are generally available. Okay. Progress report here. Server level feature gates have been introduced in 3.6. We've got client-side query that you can issue to see which features are enabled. And we've migrated most, but not all, as I was discovering with an audit, of the experimental flags. The next thing to do is to have cluster-level feature gates that apply across the entire etcd cluster as opposed to being just individual member switches. And use a raft algorithm to ensure consistency between the members of the cluster to remove a whole large source of errors that has existed forever. Final major thing in 3.6 is we did a whole slate of performance improvements. We improved the efficiency of our CPU usage. We lowered the amount of memory usage for etcd. We are using fewer snapshots, which then leads to less compaction required for the database. And as well as supporting higher rates of queries, right? So if you're on etcd 3.5, you've got a really large Kubernetes cluster, it's bottlenecking on etcd request, upgrading to 3.6 may allow you to postpone that bottleneck for another, for another 500 Kubernetes nodes before you start running into bottlenecks again. A lot of changes though, like I said, first version in 4 years, so there are a lot of changes that affect backwards compatibility. Many flags have changed. Please take a look at that. That's in the release announcement. It's also in the config doc, right? Take a look at all those flag changes before you upgrade to make sure that your system management and your config management and everything else is ready for all the changes and flags. You also need to upgrade from version 3.5.20 or later because we added a bug fix in 3.5.20 that if you jump straight from say 3.5.15 to 3.6 will cause you to get this too many learner and cluster issue and your cluster will shut down. So upgrade to 3.5.20 first. There's also a bunch of issues around upgrading that we fixed in 3.6.1, 2, 3, etc. So please go straight to version 3.6.4 if you're upgrading, because that will avoid some upgrade hiccups. And over to you, Arka.
Thank you, Josh. So let's look at the very new project, etcd operator, and it is the much awaited project that will allow you to manage your etcd clusters. So it started out as a working group, and these are the leads who are doing, and we have one of the leads here, Josh. So it started out as a effort to unify the efforts to actually manage and scale etcd cluster. So what it will help you to do is like have one place, one controller, which will help you scale up or scale down any etcd clusters. So when we actually started with the working group, we did some requirement gathering, and we we made it into a charter. And in the charter, we actually prioritized that what are the use cases of etcd operator, where is it currently used? Because many closed source projects are there around operators that manage etcd clusters. So we actually did a research gathering on that, and we prioritized and created a roadmap accordingly. And then like we created the etcd operator project itself under the SIG etcd, and also kind of a prototype of 0.1.0, which will implement the core functionality of the etcd operator. We also considered cases like etcd clusters which run on non-Kubernetes environments, and also etcd clusters which can be used as a backend storage for kubeAPI server, but that is not not in scope for this working group for what it needs to be achieved. So it's almost been a year since the etcd operator project came live and the working group was formed, and we see a steady increase in the community interest as well as the contributions. So this is an overview of the roadmap that we have, and 0.1.0 is already released, and it's a non-production version, but people can start using it to get a feel of it. So what it basically does, it implements the very core functionality. Is basically there is an operator which will allow you to create a etcd cluster object, scale it out, or scale it in, and also add customizations with limited capacity. And in version 2.0, the main feature that we are bringing in is the TLS support, which will make it production ready, as well as the upgradability of the etcd clusters. Similarly, we will add like incremental features to 0.3 and 0.4 until we reach the V1 stable. So let's look at what we did as a part of 0.1.0. So first, the code base was bootstrapped by KubeBuilder, and what it means is that like we had the entire scaffolding on which we started developing the code, and we also added Dependabot to manage the automatic dependency bumps. We added the tests to code its like test the core functionality of the etcd operator. we also had the release process in place, streamlined via release scripts, and the basic functionality itself. So the etcd cluster object, actually the CR looks very simple, if you can see on the right-hand side. So it has a size. So you mentioned what is the size of the cluster. Then you mentioned the etcd version for which which you want the cluster to be on. And then you mentioned the storage specs. And for the future work, one of the major features is the TLS support, which I'm currently contributing to. And what it will bring is it will bring the production readiness of the operator. And what it means is that each member will be tied to a server and peer certificate for communications within the etcd cluster, and also a client certificate to communicate with the etcd operator. And if you can see the spec here, so spec will look something like the provider. So starting out, we will be supporting cert manager, since it is the most commonly used certificate provider. And for that, you can actually specify a bunch of things like the organization names, the IP addresses, the DNS names, along with how long you want the certificates to be valid and rotated, and also the issuer. So issuers can be a cluster level one, which can issue certificates all across namespaces, or a namespace-specific one, depending on what is the requirement. And another thing is the upgrades, which I was talking about. So basically, we will be able to upgrade from one patch version of etcd to another, like 3.5.18 to 3.5.19 or 3.5.20. As well as we will have the support for upgrading from one minor to another. So 3.5 to 3.6, like 3.5.20 to 3.6.0, and so on. And this upgrade matrix will be baked into the system so that only valid versions can be upgraded. And we'll get into the demo. So as a part of the demo, what we'll be showing is how we install the operator CRD. We will try to create a 3-member etcd cluster. We'll try to scale it out to 5 members, and then scale it into 1 member. So let's dive into it. So I'll be installing the CRD and deploying the operator. And we'll check if the operator pod has come up or not. So it's still in container creating state, and yeah, we see it's running. So let's look at the logs. So on the right-hand side, what we see is the CR itself, which will be applied. So again, it's like it will be using 3.5.21 version of etcd, and the size will be 3. So let's try to apply it. So yeah, so if you see, it is trying to create the cluster members. So member 1 is creating, and it is trying to create the stateful set, like it's trying to scale up. And yeah, it will take some time. So yeah, the sample one, the first member is ready, the second member is also ready, and we'll wait for the third member to come up. And yes, it is doing a health check, and etcd member, like etcd cluster is ready. And it is doing it did a leader election here, event, and now we have a etcd cluster which is running with 3 members. So let's try to scale. So we'll try to scale it to 5 members. Apply. And similarly, there will be another leader election event where the leader will be elected once all the stateful set pods come up as the members. And yes, we are good. And yes, there was a leader election event and the etcd cluster is ready. Now we'll try to scale it down to say one member cluster. And that is the minimum you need to have to run an etcd cluster.
Yeah, we talked about letting people scale down to 0, but decided it was a bad idea.
Yes.
For one thing, you lose all your data when you do that.
Yep. Think. Yes. So we have a cluster which is scaled down to just one member. And yes, and we also see the status that etcd cluster is up to date. And again, the leader election event has happened. And over to you, Josh.
Okay. Well, thank you. So, one of the reasons we're here is that we want you to contribute to etcd and/or etcd operator. Yes, we are part of the Kubernetes project, but we're this kind of smaller part of the Kubernetes project that can be a little bit more accessible. If you are into databases, how many people here are into databases? Yeah, so for all you folks who are into databases, consider contributing to the main etcd. We have a whole bunch of help wanted issues in the repository, which you can go ahead and find. Some of them already have people working on them, but a bunch of others don't. We particularly look at both the main etcd, look at bbolt, which is the storage engine, and look at Raft, where we're really looking for people to contribute and do things like help improve the performance of Raft without losing consistency. For the operator project, the better thing to look at is the roadmap, because there's a bunch of things on the roadmap that don't currently have owners, where you could get started working on something for version 03 or 04 to implement that particular feature for the etcd operator. Also, help us test. Help us test different use cases, et cetera, on different Kubernetes distributions, and test the new features as people go ahead and add them to the operator. So the places you can connect with us, SIG, etcd, and Kubernetes Slack. We have a mailing list that we actually use, unlike almost any other Kubernetes SIG, etcd dev. We also have a separate channel for the operator. And we have regular community triage testing operator meetings. Right now, those are kind of late for India. I think they're at like 11 p.m. India time. We've been talking about either moving or having alternate meetings at another time to make it friendlier for people in India and also, and particularly friendlier for people in China, which the current meeting time is not great for. So if that's you, then speak up in one of the Slack channels. And then obviously when we schedule the new meeting, please show up. So, and that's it. So thank you very much for coming, and we are available for questions. How much time do we have here? We have 5 minutes for questions.
For this operator, are we using the same container images which we use as a base images when we install the Kubernetes?
Yep, it's the same release, like
Okay.
same etcd.
Okay, and from the values perspective, like for this, this is available installing using the Helm chart?
Right now, we don't support Helm chart yet. So that is a feature in the backlog, like in the roadmap, we have it. But right now, it's just a normal make deploy event.
Yeah, somebody brought up the Helm chart, but right now there's not much with the, there's not much that's configurable. Most of the features that you would want to configure are coming in later releases. So we decided to put off a Helm chart until there's something to do with a Helm chart. Okay, who is next? Okay.
So how would this work with the cloud providers, considering that they abstract the control plane? Like,
It doesn't matter. He was asking how it would work with cloud providers that have their own version of the control plane.
So the current implementation is not really managing the control plane, but to manage the applications that you want for the etcd cluster. So using etcd cluster, if you want to manage any application, that is the current this thing. But what you asked is a genuine question, and that also we have thought about. That's in the out of scope part that I discussed previously. So that will be coming maybe probably.
Yes. So currently we are using OpenShift this one, okay, and always we have problem like etcd database size, okay. So now we have I think extend to 16, but in future like is any things like can extend to 32 or some else. So to whatever issues we are facing like etcd database full, so we are doing continuous defragmentation, all these things. So is any way like in terms of performance and changing size to more, and it will be stable.
It's actually always, it's been a feature of etcd forever that you can configure etcd to allow a larger size, right? I mean, the problem is it also does a larger static memory allocation. So the reason why we have the default smaller size is for most people, it means that they're not doing a lot of extra memory allocation, right? But if you know that you need a bigger one, that actually is, look in the configuration documents, like right now you can actually restart it to be bigger. Pretty sure there's something in OpenShift for that.
Like if you are changing, it always your stability issues. So if you are changing database, like we are using raft querying, all these things, all things it should be still sync to all others. So in terms of stability things, it will matter when we are changing to 32 something else.
I don't think I'm quite understanding your question then.
Actually, he is not meaning about memory, it's a size, DB size.
Yeah.
So currently HCD documentation recommend go with 8 GB, not more than that, right?
Yeah.
So our question is like, can be in future roadmap we have any project or something which we aiming of a bigger DB size, so that we can accommodate more data.
Yeah, and one of the things about that is etcd is a really simple document database. And so one of the reasons that we recommend 8 GB is that at larger database sizes, you start getting more performance problems. So in effort to make those larger database sizes palatable would actually be a performance engineering effort, right? And remember how I talked about that we really are looking for people to contribute to bbolt? Well, guess what? That's actually sort of a major thing. The other thing that within the Kubernetes project, we've been talking about some of the reasons why people have really large etcd databases for Kubernetes. And one of the reasons is CRDs. And so one of the things you'll find is a discussion issue within Kubernetes is open for, is there some way we could have a second etcd just for the CRD data that's separate from the main etcd that we're using for the API? Because that would actually be a solution for a lot of people. Because CRDs both store a lot of objects and they're very talky. They write updates to etcd all the time.
So you said that we actually support the slide was showing that you could downgrade is actually the reverse of a rolling upgrade.
Yeah.
So like I have a 5-node cluster, okay? I have a 5-node cluster and then I downgrade one node. So one runs with the older version and the remaining runs with a newer version, and it works consistently.
So upgrading it by shrinking the cluster and then updating?
I upgraded the cluster and then some issue happened, so I want to downgrade now.
Yeah.
Okay, so I
Yes.
downgraded one node and then I have to go to the second node, I have to go to the third node, rolling, correct?
Yeah. Well, the part that you have to do manually or using a different tool is replacing the binaries, the actual etcd executable. Needs to be replaced on the individual nodes by whatever mechanism you're doing that with. Everything else runs through the commands that you send to etcd, the downgrade commands.
Yeah, that I got it. So I have a 5-node. I replaced it on one node.
Yeah.
I downgraded one node.
Yeah.
Okay, now I'm going to the next node.
Yes.
So that time you said there is no downtime involved. So the cluster will continue to run.
Yes. Yep.
So
Yes.
the 4 nodes will run with a newer version and the 1 node with an older version and it will run.
Correct.
Okay, that's cool.
Yep. We have time for one more short question if anybody has one. Okay. Let's take one question from somebody else.
So my question is, does the operator take care of auto, compaction and defragmentation?
That is a property of etcd, so it will. So any of the etcd members, it will take care of it.
Okay. So currently, all the maintenance operation needs to be done, maybe during the downtime, etc. Right? So does the etcd operator in specific provide, option to periodic fragmentation? Defragmentation.
So you mean full defragmentation rather than
Exactly,
the background
because
defragmentation?
the actual DB size may be 8 MB, but the the bolt database size may be spiked up to till 70, 80 MB, which we see.
So currently it does not support that.
Okay.
And also, I guess that is a property of etcd that we need to do. Like from an operator perspective, we are just managing the members and the scale.
No, because etcd server in itself exposes the RPCs to do
Yes.
that.
We don't have a specific item on the roadmap for that, but it is the sort of feature that we would want to eventually add to the operator.
Yeah.
Okay. No, thank you.
Yeah. It's not going to eliminate the downtime though for doing full compaction, right?
Yeah.
Because full compaction involves rewriting the data, which means it has to be done on all members, so you can't do it in a rolling fashion. Okay, well, thanks everybody. If you have more questions, ask them in one of our Slack channels or the mailing list, or find us later at the conference. So thank you.
Thank you.